Oh my, I hit start recording and this double click on this mouse, it has a double click, okay? If I don't press it like hard and release like this, it like double clicks for some reason. Anyways, welcome back. It's day 60. Oh, why did I start doing this? 61 of coding every day. So yesterday we worked on those Leetcode problems, hooked up the extension to the Leetcode whatever so that we could keep track of a repository of those. Um, then we looked at code visualizer and it's in a pretty rough state um, with large language model generation. Um, and um, and then we looked at like jobs and what technologies they're looking for. So, I've already been coding for quite a bit today. Um, and I wasn't recording just because I'm working on that the video that I wanted to, but I'm like if I just keep working on this, I'm gonna have no time. I'm like I might as well just work on it while I'm recording. So we'll do that. It's pretty like I'm not even like I'm like half-assing the syntax, just ChatGPTing the rest because it's like I don't really care. I mean, I should actually learn the Manim code, so maybe we'll scroll through. It's just there's so much like documented stuff. It's like learning a new language, because there's just so much in the library that it's a completely different. You know, it's Python, but it's not. So we'll look through that. I'll show you what I already have in the topic of that video. Then I also wanted to go through what I have pulled up already, which is one of my classes, the syllabus, which is my algorithms class. So we'll look through that, kind of see what it's going to go through, and yeah. So so yeah. So we'll do some. I'll look through the syllabus, and then we'll do a Leetcode or two, and then um, and then we'll work on the video. And I think that's it. I think that's all I'm going to do. So aim for like an hour, hour and a half, maybe 2 hours on this video. Because I do want to eat soon. Because I woke up at like 8:30. Um, and then what did I do? I made coffee. I think I cleaned up a little bit, and then I did a load of laundry, and then I've been just working on the video and random stuff since then. So yeah. Um, so yeah, we'll go through the syllabus, and then uh, I'll show you the video, then we'll do the good. So yeah. Okay. So should scroll in here. Um, Stable matching, algorithm analysis, graphs, greedy search, divide and conquer, dynamic programming. That'll be fun. Also, what I plan on doing is see now this is a little weird. Is I was my plan is to take is just go through like the textbook on here and like take notes and then like I'm treating this algorithms class is more like a math class, right? I'm pretty sure it's like theoretical stuff. So um so yeah, I'll see how I want to approach that because I don't think I can show what am I trying to say here? Show the textbook because it's a behind a paywall that I'll have to pay for. I'm not sure what network flow is and interactability. So we'll have to see. Um, yeah, this is the grading, which is not bad. It's like 50% of like homework participation challenges, and then 50% exams. So I've seen worse. Um, I wanted to see this. So cross-cutting, use reason about algorithms. Use self-regulated learning to solve problems that require execution assessment of data. Okay. Okay. Basic of algorithms. Big O, big omega, big theta. Graphs, understand graph traversal. Greedy, design greedy algorithms. Yeah, it's pretty. We've done a lot of these. Divide and conquer. We've done these many times. I'm pretty sure divide and conquer is like just search algorithms now. I think no, greedy algorithms are search algorithms. Um, divide and conquer. Maybe I don't know. Dynamic programming I haven't worked with, and network flows is weird. Okay, that's all I wanted to go over. Nice. Yeah. So this is the thing that the Manim like documentation like is it looks good. It's just a lot that you got to go through. So animation, cameras. That's cool. Yeah, we'll go through all this. But right now, I'm using VS Code because VS Code has an extension that I can like preview the work right here. Um, so anyways, we'll go back to the start. Um, so I had the idea of doing recursion for the video, which is a little ironic because in the last time I was not struggling, but like I still have not full clarity on recursion. So I was like, why not make a video on recursion? And that way I'm going to have to research into recursion, therefore learning it. Now that's a little tricky because it's like, okay, if you're trying to make an educational video about something and you yourself are not to be an expert on it, but not even like confident on it, you have to kind of question that. So I would say if I get to the end of making this and I'm not 100% confident that I understand recursion, I just won't put it out, right? But I feel I have a good grasp of the concept currently, and I think given a couple hours of dedicated time to perfecting that is going to be enough. So currently I have this. It's this goes up and it says, the definition of recursion, which is just recursion is a method of solving a problem where the solution depends on the solutions to smaller instances of the same problem. And I just got that from multiple repeated stuff. And so then here I was going to talk about that recursion stems from mathematics, right? And so here you have the function f of n or whatever, which is equal to a piecewise function that says if f of n is less than or equal to 1, then 1. Otherwise, recall the function with minus 1 plus a recall the function minus 2 if n is greater than 1, right? And so this piecewise function, you know, it keeps calling itself to do something until it gets to a base case, which is, this. So then it goes into a code example of saying, which I think I want, yeah, I haven't re-rendered it, but I took those line numbers off because I don't know. I don't know if I want to keep those, but just Fibonacci with n, if n is less than or equal to 1, return n, otherwise return a call on this. So this is the exact same thing as the mathematical function, right? It's showing the exact same thing. And so it's like, this is what it stems from. And then I show both of them side by side because they're the same thing. And from here on out, I'm not going to use. See, this is also something I'm not sure of because it's like I'm trying to imply here that I'm not going to use just like pure math, but I might. I may. And then here it looks really bad right now, but it's going to be something of stepping through the code and just like trying to visualize what's happening. Now this is the horrible animation because it doesn't actually show you what's happening. It's saying we call fib on 4, return fib n minus 1, right? And so it's going to go through with an n minus 1 plus fib n minus 2. So the results of this in this. And so there should also be, it needs to be something practical as well. So I'm going to do something where it's like if n equals this, these are all the calls that are going to go through. This is what's happening. These are what is changing the exact step through. So that's like, it's like I'm just showing a simple, very simple version of this. And that's going to like end, I guess, the introduction period of this. Um, and then I'm going to dive into actually, I wrote out or helped with ChatGPT to write out a script, and it was kind of along the lines of, um, I changed it up a little bit, but I didn't like the hook thing. Defining recursion, doing a simple example, and then mentioning, oh yeah, I want to mention the use cases of recursion. Not all of them, obviously. Um, and then there's actually more. Oh yeah, here. And this part, how recursion works. So talking about, so this won't go into too much depth. This will just be like an overview of what's to come. So it'll be something like definition. Um, definition in the introduction. There'll be a definition into, clarify. I'm only going to be going through like the programming side of things, and then going into a simple example. I think I should turn this around. Actually, it probably should be like this, like how recursion works should go before a simple example. It should be, or should it? Should you show a full picture? I guess it's better to be like, let's show an example and then break it down, right? Of like, here's the example. Or actually, what it should be is it should be mentioning mentioning this, like use cases, then going into a simple example. Well, actually, this should be the introduction. And then you go here. So a simple example. Um, and then say, okay, so this was the base case, this is the recursive case. Um, and just go through it. Go through just the base case and the recursive case at like an abstracted level. And then the next part would be going through um, showing like how calls are stored, visualizing the stack and, going back to previous calls and stuff like that. Um, and then something pretty intricate, something that isn't so overview, but is literally showing every single moving piece of recursion of what's happening at once. So that will probably take a few hours to piece together what this part two part. Um, and then after I can do that, right, then it'll just be a conclusion. So if I can do recursion and action for two different examples, right? Fibonacci, I might change this example, but two things, show them very well in depth, and then just a quick conclusion of everything. Yeah. So that's the idea. Um, yeah. So I have to end up moving that. Oh my god. Tired. Okay. But on to Leetcode for now. Okay. I think we'll put on some music one sec. Okay. By the way, I think this music is copyrighted, but not like I'm monetized anyways. Leetcode 75. Should I just go top to bottom? Commit to solving two problems every day. Oh, Oh, I see, I see, I see. What do we want to do here? I would say I can solve. Let's just do one a day. Let's get it. You're given us two strings. Should probably make this a little larger. Actually, I should just make this to 21. Okay, that's a little much. 19. Two spaces. Beautiful. Actually, I hate that. Go back to 4 space. Also, I like relative line number. Okay. You're given two strings. Here, I'll go to compact. Two strings, word one, word two. Merge the strings by adding letters in alternating order, starting with word one. If a string is longer than the other, append the additional letters onto the end of the merged string. Okay. So just a, isn't this like a while? Word one or word two, right? As long as there's stuff in either. You just have like just like an index. And you just say word one at index. Then we'll also have a result array. Oh, it is a string. We'll still just do an array. Are you able to, I think you're in Python able to do indexing of a string. Word one at index, not append. Well, sorry. Res dot append word at index. Res dot append word two at index. Oh. So that'll append this and this, and then we'll say index plus equals 1. And we keep going. And then at the end, we just say well, actually, you know what I can do? Is I can say length is equal to the minimum between word one and word two. The minimum between the length of word one and word two. So that will give us the length. So we want to say if, now we want to say this -1, and then we can say while the index is not equal to length, do this. And then at the end, it's got to be a better way of doing this, but it would be if word one well, actually, we can kind of figure out like if the length. Oh, this is very inefficient, but it's like if the length of word one is equal to length, right? I want to res dot append word one from um, from index onwards, else res.append word 2 from index onwards, and then return results is going to be equal to dot join just res. Do I have to map this to anything? I don't think so, because it's already a string. Let me see what this does. A, P, Q, B, A, P, B, Q, C, R. Do I want to do this? Let me think. Length would be equal to 3. Oh, yeah, we would, because it won't be inclusive. Okay, A, P, B, Q. I need RS, which this isn't working. So the length of word 1 equal to, okay, so now it's going to be the length of word 1 equal to the length minus 1, right? Well, no. Oh, this? Beautiful. Um, because I was looking at minimum, not maximum here. And so we want to say, if this is the maximum, basically, it means that there's going to be more elements if there is a difference. Surprised this is an error on whatever. Also, it's nice that this worked easily. Usually I get that wrong. Cool. Okay. What could we do to make this more efficient? Because right now we have a while loop. This is still O of N, I'm pretty sure. We have 2 strings and I would say O of N. Yeah, okay. Um, Python for A and B in zip word 1, word 2. Merged dot append A plus B. Yeah, I don't like that. Output dot append. Oh yeah, wait, you could just do, if that wasn't giving an error, I could just do this, right? Because technically, that got worse. And it took 45 milliseconds. Was this actually better? Wow, that's funny. Is there a way to improve this? Maybe instead of doing this, we do just like a a for each, or no, for index in range of length. Right? Let me see if that works. Maybe it's a length minus or plus one. Um, for index in, so length is word one, which is the length of three. So is it minus one? Plus one? I don't think so. Yeah, out of range. Well, why wouldn't this work though? I want to know why this doesn't work. 0, 1, 2. Oh, because right here. Um, I don't think there's any way to get around this. Yeah, I'll just go back. It was fine. Ah, we'll just go with this. If this just says, wait, do you think dark mode works with this? Oh my god, it does. This dark mode extension is perfect. Greatest common divisor of strings. For two strings, S and T, we say T divides F if and only S equals to T plus T plus T plus T. Concatenated with itself one or more times. Given two strings, return the largest string such that, okay, A, B, nothing. Okay. I mean, this is brute force. It would just be compare each index until an index is no longer equal. Now, there's definitely an ed, like, let's say it's A, B match, right? And then it ends. But then the next string. Ooh, you know what you could do? Are these distinct? No, I think it could be like A, B, C, A. I was gonna say you could use a set to avoid duplicates, right? Let's first just see if I can just say like, um, I don't know if this is necessary, but length is equal to the minimum between the length of str1 and the length of str2. And then we say for index in range of length, if str1 at index is equivalent to str2 at index, right? Then again, we want a result array. Or maybe I don't even need that. I just say, maybe I say this, and I just say res plus equals, or I could say res is equal to str1 from everything up until current index, right? Um, else break, return res, right? So in this example, we'd have 3. So it goes 0, 1, 2, right? So if str at 0, which is a, is equal to this, then res is equal to str up until 0, I'm pretty sure. This might be index plus 1. Else, at any point, if they're not equal, just break. Let's see what this has. I think it's going to be a plus 1 on index. Oh. So could I do this with a set? The set of this would be AB, and the set of this would be AB. Oh, you know what I could do to check? It also has to be I don't know if this works, but it also has to be if str1 I was going to say if like the length of the opposite 1 modulus the length of the current, but nah, that's not really. I guess so, right? It has to be. If I say check is equal to the max between the length, right? If check modulo the length of this, right, is equal to 0, then I can do this. A. Oh, that is true. Damn. Oh, that is true. I don't want to just keep putting in checks, so the other check would be taking. Because the other check would be if this, right, what we're trying to add is equal to this from just index plus 1 plus index plus 1. I think this might be index plus 1 plus. Let's print. Jesus. This has to have an error. Sorry. Put the print there. A and then nothing. A B C A B C and then A B. Maybe I want everything from index. Let's run that and see what's up. First is A, second is nothing. First is A, B, second is nothing. This is just supposed to be from index. It might be index minus 1. Why is second nothing? Oh yeah, no, I want that to be. I don't think this works. No, because we need to set res. So if our current snippet So we're at index plus 1. We're at 1 on this first value. Eventually, we're going to get to like 4 or 3, per se. Like we're going to get to, we get to 1. Well, ideally, it's going to be A, B, and then we want to check everything from index 1 up until 4. So 1 to 4. What would 1 to 4 here be? It would be index. It would be from index to index plus index plus 1. A. Why would that be A? Okay, let's print off this. So A, B, C, C, A, B. So it's wrapping. Why is it wrapping? Because we are checking string 1. So it should be string 1 from... So if index is 2, but this isn't inclusive, so at 2, 0, 1, 2, is it really including this? Is this really an index minus 1? To index plus index? A, B. Then on 2, wait, what happens if I just change this back? It's just index. This now just becomes B. Okay. 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 If we're at index 2, oh, I need that. Here, let me print off also str1 at index. Just see this. So we're at A, then we're at B, then we're at C. So we're at C here, and it's taking this C in this A. So I want index plus 1. Is this index plus 2? But see, we're printing this on... I don't think this works. No way. It's going to hit some sort of weird edge case. Yeah. Yeah, that is a problem. There needs to be something more robust here. If I do a set, it is going to remove all duplicates. Meaning in this case, we would just get A, B, C. So what if I did that? Here, let's try something here. If I said str1 Python string to set. Let's just print string1, string2. Just see what this looks like. C, A, B, A, B, A, B. A, B, C. Why would this be C? Why would this be C, A, B? You would add A, then you'd add B, and then you'd add C. Then you'd add A, which is a duplicate, so possibly it removes that first A and just puts A there. And then it adds B, removes that B and puts that, and then C. And so you think it would remove that and put the C there, so it'd just be ABC again. String one at index. This is string one. Oh, that is true. Oh, I guess it's, wait, can I just do, can I just do if string one equals string two, turn res, else? Does that work? Sorry, return. Of course, of course, of course. Man, there has to be something. It has to be something with a set. It has to be. It has to be. Why am I just like failing to get this? Using recursion. Let's think of a recursion. If you go all the way back, right? If we go all the way back to this stuff, right? So the problem here um, was that I had A, B, A. Now, what if I had a recursive function that said, or I just had a function that said def check um, check res, right? and you pass through str. And so what happens is you say okay, res is equal to this, or how about I just say test is equal to this, test string is equal to this. If check res I don't think I need this. If check res with test str, if it passes, and return test str. And the base case would be return this, right? Because then it's going to go through here and it's just recursively going to say if, and I should say index, which will start at 0. If index is equal to the length of str, not str, equal to the length of what we're comparing it to, which would be str1, return true. Okay, so that's our base case. How long have we been going? A little over an hour. All right. I should probably turn it. We'll turn the light on. We're doing this in the dark. So we want to say index plus equals the length of str. So if we're at 0 and say str is, we first get a hit on a, right? If we first get a hit on a, or say AB, we got a hit on. We want to check starting at index 0. We want to start from, yeah, plus the length. Okay. And we want to say, okay, if str1 from our current index to the length of str, maybe plus 1, will index plus the length of it. So if this is equivalent to str, right, then we call check res again with str and index. I was trying to think, is it ever going to... You should probably have the index of what you're checking go through first, right? So instead of doing this, oh, index is now equal to this. I'll do this here, right? Index is now and so this is originally going to be passed through with the length of test str. Else, let's try that. How many times do we get to this? So we go through on A, AB, and ABC. So ABC should be a hit. Why is it not? So let's see. Print this. Did I get rid of this print? I did not. Nope, that's checking correctly. So let's print index. Well, let's print the length of str1 and index. Wait. Return true. Oh. It's because I need to do what? This? There we go. Please? Damn it. I guess the way to get around this would be instead of returning or returning true is fine, right? But having result equals this again, and then just have res equal test str. Right? ABC success. Please? This should be the maximum. So close. AAA is success. Wait, is it just comparing all of STR2? Like, do I not need to get STR1? Is it all of STR2 is in there? No, it's the largest element that divides both, but it has to take up all of both, right? That's kind of the problem here. It has to take up all of both. So I guess the only change I'd have to make is not only comparing. You'd have to check this against not only STR1, but STR2 as well. Okay, so what if I put length, right? If STR1 is equal to this, wait. What is STR that's getting passed through? That's the check. So if I said if the string, whatever string in the length of this is equal to this, right? And then it would be the length of whatever string. So then I would have to add if this and check res on test, still test STR, but now I also want to pass through STR, the length of STR2 and STR2. How does that go? An object's not callable. Where? Oh, right here. If the string Oh, sorry. I also need to call this on. Well, length doesn't change, and the string doesn't change. Uh, I don't turn on the light. God damn. For an easy, quite struggling with this. Oh my god. I can't call it len. Please, please work. Let's fucking go. I can't wait to see how easy these solutions are compared to this. Oh my god. This is quite the solution here. See, this is the one that I was gonna look at, or the one that I was, yeah. If the first string plus this is not equal to those two strings together, return if str1 plus str2. Oh, that is smart actually. If them combined is not equal to them combined, right? Because there's the same thing repeated. Return that. If they're equal to each other, then return str1. This is assuming it passed that first check. Otherwise, if the first string is greater than the second string, it means that there's a possible difference. So you return the recursion of the first string from the length of the second string onwards, and then str2. So it's just cutting out that prefix. And then it's like, okay, let's keep cutting out until they're equal to each other. And then, wow, and then you just, wow. Why is this return at the bottom needed? I don't understand why with str1 and str2. That is really smart. I mean, yeah, it makes a lot of sense. It just the last part I don't get. I mean, this is in the case, obviously, if string 1 is less than string 2, in which case, I mean, it's just the reverse of the other thing, but I didn't think that could be a case. Let me just see. If you were to just do this, does it not just run? But in this case, str2 is still less than. So actually, I guess my question is, why not just this? Oh, because eventually what's going to happen is they're going to be either equal to each other or it's going to flip. Ah, that's why. I see. I'm just going to submit this. I like my actually, you know what? In this scenario, check is always going to be str1. I'm pretty sure. No, come back. Description, there we go. Right? Oh, I never even used that. Yeah, I do. Actually, other way around. Right? Out of range. Well, I had this as length, so the minimum between these two. STR1 can be less. Never mind. Never mind. Okay, then we'll go to classic mode and upload this. Accepted. Amazing. So now we can go to our GitHub. There we go. Beautiful. All right. I think I'm gonna end here because I was thinking about it and working on that video is just gonna be boring for viewing experiences. So um, I'm still getting copyright stricken on this video. Anyways, I'm gonna go make some dinner and then work on the video and I'll show you my progress tomorrow. So pretty chill day, honestly. Listened to some music, did some Leetcode. That second problem took me a lot longer than I wanted it to. Um, but it was a cool solution we came up with. But yeah, that the other solution was really smart and intuitive. Um, I don't know if that kind of stuff just comes with like practice or it comes with like developing a different way of thinking about these problems. I assume a bit of both. Um, but like it is like once you see it, you understand it. And so it's like, the idea that there's a string, like a prefix that is going to fit into the entire string and this entire string, and either one can be a certain length. If you concatenate them together, right? Um, it should be equal to the concatenation of it oppositely concatenated, right? Um, that's pretty smart. So I don't know. Um, anyways, I've been talking quiet because some roommate showed up today. Um, but I will be back tomorrow, probably in the morning. I have class tomorrow. Um, so at around, I don't know, I think 1:30 I have a linear algebra class. So we'll probably record in the morning before the class because then I'll probably eat while I'm at school and then come back and work on the video more because I would love to get that out um, on Friday. That'd be really cool. Or sometime over the weekend, but I had the goal of uploading one a month. So if I wanted it to be one a month, it would be Friday I upload it. All right, anyways, I'm going to go get something to eat and work on the video. So I'll see you tomorrow. Bye.